Let's say you want to rotate this image by 90 degrees. Okay. So what you can do by 90 degree rotation means, if you remember last time, this is rotation, right? So if I put 90 degree here, what was the equations used to? Yeah, so we have x dash equals to minus y, and y dash equals to x. Okay, so this was like the equation, which means that x and y are the original coordinates of the image, and x dash y dash are the after rotation, right? So this is 0 0. Okay, now you have 0 1 0 1, x is 0 and this is 1. So what it will be? This is minus 1 and this is 0. So new location of the pixel that belongs to this location is minus 1 0, right? So where is minus 1 0 now? So this is x-axis, right? So I said if this is positive, the negative will be here. So where is the location? Here. Oh, sorry. So the location is there, right? Yes or no? Okay. So it means, okay, now this is the location. So what will be the pixel here? 0 0 was 1. So here it will come 1 and here it will come 2. Okay. Similarly, this will go to minus 2, which is here. So 3 will go here, 1 will go here, like a negative axis. Fine. Okay. And similarly, the others, okay, we were doing some point processing. So what is point processing on the pixel based operations? There are different names, by the way, for this one. Point means just one pixel. So we can also call it a pixel based operation or pixel processing or point based operation. So point processing is the name of all the same. Okay. So what we are doing is we are just taking one pixel at a time and trying to modify its value in order to make it look better. What is that better? To make it more suitable than the original image. Now it depends that what is suitability. Okay, it depends on the specific applications. Okay, doesn't mean that more bright or more dark makes sense. Okay, so we discussed this and we said how many operations we generally have. Either we have a pixel or point operation in which one pixel I can change it to another pixel by doing some operation on it. Okay, or I take a bunch of pixels in order to find the value of a specific pixel. Okay, so I'm just taking a neighborhood pixel, right? And the third is if I take the whole image, try to find something into the transform somehow. Okay, so we discussed this for the point operation. We can have some graphs like this. We will discuss this in detail in the next slide, so I'm not discussing it here. Then we have a local, which is like taking some local pixels and trying to do some operation, which is the example of this is the filtered operation that we will discuss again after the histogram equalization. We discuss this. And the global is neural networks. I can put this image, output this image. So let's say I'm transforming these images by taking all the spatial information. Right? Third can be like, let's say Fourier transform. So I'm taking the Fourier transform of this whole image to find something else. Okay, so it makes sense. First part, which is the basic intensity transformation, where we transform each pixel to another pixel without caring about the other neighboring pixels. Okay, so it's like a pixel by pixel operation, right? Here, let's say I want to make it black and white. So I say, okay, the pixels greater than threshold, mark the 1, less than threshold, just make it 0. So it's 0 and 1, black and white pixel. This is good for segmentation. And then we can also add some specific value to a pixel, each pixel, let's say 20. So if I'm adding some value, it means that I'm making all the pixels towards the right side, right? Because 0 is dark and 255 is bright, right? Okay, so why point operation? Point operations is good for the image that is too dark or too bright. Okay, and we'll discuss some examples. Now, what are the point operations? We can categorize the point operation into basically four type of methods. One is either linear, one is identity. Identity does not make any sense here, but let's say negative. Okay, I want to basically make the opposite of what we have. Okay, the 0 will become 255 and 255 will become 0. Okay, so I'm taking the negative of that. Okay, why? I mean, what's the application of that? Yeah, medical image is one of the application. Okay, or we are just using filter in our mobile. Okay, sometimes we want to make the negative. Okay, and then logarithmic curves. Okay, if you see the log curve, it is like this. So this is the input pixels and this is the output pixel. So if we are doing this, what we are doing? What is the effect? What do you mean by this? And it means that I have to map all the pixels to a new value according to this curve. Okay, yes or no? Yeah, for example, this pixel, which is L by 4, okay, will be mapped to this. Okay, so what is L? Let's say L is 256 by 4. What is 64? 64, right? 64 will be changed to 3L by 4. What is 3L by 4? Okay, 190. Fine. So it means that we are changing according to this curve. So it means that lower ones are the darker one or the brighter one. We are changing darker to lighter one. It means that we are basically when we have this type of curve, okay, we are making the image now. We have a log, which is this. So what will be the opposite to this? Inverse log, right? So what is okay? What it will do? It will do the opposite operation. Okay. So if your image is lighter, it will make it dark. Okay.
So I'm just given the middle line. So if I want to go up, I go this curve. If I want to go down, like this.
Yes. Okay. Now, but the problem again with this method is you can have just this curve or this curve. You cannot change this curve because the log is log, right? In order to have more like degree of freedom, I have which we call it power law. Power law is if I can take the nth power of the pixel, I will get this curve, and this depends on the value of n. We can make steeper, more steeper, or straight. Okay, it depends based on. Similarly, the opposite is nth root. So based on the value of n, I can make it more curved or straight. It depends. So here we will have more degree of freedom based on our application. And then we have piecewise. We'll discuss. This is not here. We'll discuss it. This is a separate method. Okay. So we'll discuss one by one all of them. Okay, so how this is done basically in a computer? Okay, this is a kind of a lookup table because you cannot give a curve to a computer to fit it. So either this is a lookup table where I say okay, the pixel with a value of 64 will be changed to 32. Similarly, 128 will be changed. If we stay as 128, 192 will change to 224. Right? This is based on what we do. But no, we don't need this. We should have all the values. Okay. Yeah. The other way is if you have equation. If you have equation, the first one, and we already discussed this. The negative is what? Just subtracting each pixel from the maximum value. Not. But what is the maximum value?
It could be 255. It could be lower.
Yeah, highest conversation level. Okay, -1. Okay, so L is like 256. So L will not be the highest level of the pixel, but the highest level of the quantization. Okay. R is the pixel value, whatever pixel value. The original image, we take the pixel value, put it here, and you will get the opposite to that. I have the example. I think I showed you the example. Okay, let me show you the example. Okay, so what's the application as I mentioned? Like in Medico, let's say you have this image. This is okay, but maybe it's not very clear. Let's say these joints are not very visible. Let's make it negative of this, and you can see if there's something that doctor can tell that okay, there is some issue. I think this is much clearer than this one. This is a real picture with the negative. Although this does not have any advantage here. But like for example, somebody is using filter on this, just for fun. The other was okay. As you said, what is R? R is any value with a pixel. Okay, so let's say 95. We have okay. How many we have here? What will be L? 1 to 8. Also, the bits are given. So, what are the quantization level? 2 power 7, right? Yes. Okay. So 128. So what will be L? What will be L minus 1? 127. 127 minus 95. 127 minus 22 minus 5. You get it. Okay. So again, log, as I mentioned, this will increase the brightness. Okay, log, and similarly, the inverse log will make it dark. So what's the benefit of making it lighter? One is like if your image is darker, you can make it lighter. And the other application of that is in the Fourier transform. Let's say I take a Fourier transform of any image and I get this thing. Okay, how we get it, we will see later on. But if you see, there are some components in frequency domain which are darker. So if I apply this one, you can see there are high components in the frequency domain which becomes now enhanced. And now if I go back, spatial domain, it will make my image there. Okay, so. Okay, so this again example, simple example. I want to apply a log operation on this image. Okay, with the c as either constant equals to 1 or c equals to again some log expression. Okay, so I think it's easy. I have given a bits as 7. So what will be L? L will be n equals to 2 to the power n, which is 128. I can put this value, find c, and then in order to find this, I just take each pixel put here. I get s. Okay, like this one. So here it's every pixel becomes 2, and here in this case it will become something else. Okay. I think it's just a quick calculation just to show you how to perform. It's not a very difficult. Let's say, okay. So it means if I apply this in a spatial domain, so we already discussed it becomes lighter, right? So if I do it here and then go back, what I mean, I'm actually highlighting all the components of the frequency, right? Especially the high components. If I am highlighting the high components of the frequency, it's to try to see where is the information of high components in the spatial domain. In the spatial domain, where are the high frequency components? Here.
It's the high frequency components, and you repeat it.
Right? What is high? What is low? What is high frequency? What is low frequency?
Rate of change.
This is high. This is low. This is low. This is high. Right? So it means that when the changes are more, when there are edges, okay. So if I'm doing this, it means that I am basically highlighting the edges. Okay, so it will become more sharper. Okay. So there is different effect. Even here we make it brighter. Here we make it sharper. Okay.
So what do you mean by frequency here? Like I have to say here 250, and then the change is like 7, like big gap.
So what do you mean high frequency?
When you say frequency, so you mean that the rate of change in this value to the next pixel value is big? Is that what you mean?
This is frequency. That's big. Big jump. It means that this is high frequency. That is small. It means that this is low. This is low. We'll discuss again here. The same thing we'll discuss it. Now see, for the log and inverse of the log, we have just one curve. We don't have any degree of freedom. The slope or the steepness we cannot define, right? So therefore we have a power law. Okay. And this power law, what is power law? This is this. And we take a pixel, and based on gamma value, which is the power of R, we can define our curve. Let's say this gamma is 1, it will be just straight line. So now if this gamma value is, let's say, less than 1, it will be this curves. If it is greater than 1, we have this curve, right? So what we are doing here and what we are doing here. Okay, here we are actually for less than 1, we are enhancing the dark case. So less than 1, we have these curves, and greater than 1, we have these curves. So if we take the extreme case, we can understand these curves, and if we take the extreme case, we can understand these curves. So this is very clear, right? If I take this curve, it means that these darker regions I am mapping towards the brighter. So making these darker as a, I'm just making the whole image as a brighter, right? And this is actually the opposite to this. So, what is that? Yes, yeah, we did not discuss about it. It's a small number just to avoid when you have R 0, the pixel 0, it will not, if R is 0, you cannot transform it, right? Because it will be 0. In order to make it have some change, I just add some small number. We can also have another definition of that. See, less than 1 means we expand the value of dark pixel. Okay, because we have like this curve, so it expands the value. Okay, or compresses the value of brighter pixel, because here the brighter pixel are compressed to a small location, right?
So when you use the word enhance, you mean we're extending the region.
Extending the
So if I'm extending the light
yes.
region, it becomes
Enhancing
darker.
is, yeah,
When I extend the darker region, it becomes lighter.
yes. Okay. Fine. So let's say this is the original image. If I make this value, the power equals to 2, what do you expect? More dark. More dark. So it becomes more dark, right? Although it's not really clear, but it's become more dark.
I think it's clear.
It's clear. Okay. So now with less, become more brighter. Yeah. Although you cannot see anything here. Even here, nothing can be seen, but you can see. Yes. Okay. This is just an example of the same thing. If we have the power equals to 2, c equals to 1, you can put the values and try to find this just to give you more insight. This again some examples of the medical image. Okay, so what we did, we just used different values to make it lighter. You can see it's okay as compared to original image. This is much similarly. This is brighter. So if I'm brighter, I want to make it darker. I have to select the power less than greater than 1. Okay, so this is 3, 4, 5. You can see that it's becoming much more clearer as well because it was very bright. Okay. Then so we discussed linear, we discussed log, we discussed formula. Okay. Now we have piecewise. Piecewise means that we are processing pixel-wise, but we have different piecewise curves. Okay. Let's say contrast stretching. So how to do that? Let's say instead of like previously we had very smooth curve like this or this. Now we, for this set of pixel, I have this slope of light. Then I just have another slope and then another slope. Okay. What is the benefit of the stretch the contrast? Okay. So what is this? This is doing. This is actually shifting, stretching the lighter towards lighter and the darker towards darker. And what is the benefit? You can see this pixel, this image tells this image, which is very clear. Even you can see the spots on these grains. So this is again thresholding just 0 and 1. But anyhow, you can see that this is how much it is clear, right? Yes or no?
Contrast difference between
Difference, right? So I'm enhancing that difference even more. Okay. So what I'm doing, the darker side, I'm just making it more darker. The lighter ones, this one, making it more lighter. So I'm actually creating more difference. Okay. This is what it means. So now see, if I give you an example, a matrix, how you can find and give you some this graph, how you can find, how you will transform it to the contrast stretching image or enhanced image.
take the function for each region.
Which function? How to make function? Can I make a function? This is a straight line. Yes. Okay.
And just the domain would be like from 0 to whatever, all over, I don't know.
Okay, so yeah, so that's very good. So we have, let's say, pixel values 4x4 image. Okay, and I want to do a contrast stretching. I've been given R1, which is this value, which is 3, R2 5. Okay, and what are the number of bits we have here? 3, right? How many levels we have? 8. Okay, 8 levels, right? Because we have 7 here. So I need to show you how to find this. So okay, let me just write the formula for someone if you want to calculate which type of formula we can use.
This is the hardest one.
No, I'll give you this one, simple one. Let's say this one. Okay. So what is m? M is the slope, right? So how to calculate the slope?
Delta y over delta x.
Yeah, slopes are already there, right? Yeah, delta y over delta x. So slope of this is alpha. Okay, this is beta, and this is gamma. Okay, so you can just find the slope by taking 2 points x and y and find the slope, right? Put the slope here. What is y1? Y1 will be the the early y-intercept, and yx1 is the x-intercept. Okay, so if I put these value here, what will be y and what will be x here? What is, yeah, so this is s right here, and this is r. Now please make sure that this x and y is not the x and y that we are discussing inside the image. Okay, which we said this is x and this is y. This is for image. This is xy prime. Okay, so now for the contrast stretching, there's another way as well. Let's say I don't want to change the whole image, but some part of that image. Let's say I say here, you see this is the linear curve, but only at that point I want that pixels to be highlighted more as a dark.
Part of the image, not
Yeah,
all of that.
not the part of the image. No, yeah, part of the intensity.
What do you mean?
Let's say intensity goes from 0 to 255. I don't want every pixel intensity to be changed. Only maybe between 100 and 150 I want to change. Okay, because of some reason. I will show you the example. Okay, here now. Okay, so be there. Just to be with me. Now here, what I am doing is I am making it constant here from 0 to 8, constant value, and here I'm just above again the constant in between. I'm making it brighter. So some pixel I'm still making black and white, but not exactly the black and white. The part of some part here I'm making it brighter. The others I'm making it darker. So it's like it's not the thresholding itself, it's like kind of maybe you can call it the double thresholding, okay, that we have A and B parts. Okay, so what it means, you see here, this is some sort of, maybe you can call it a cable or something, okay, but here we have some shape. Okay, so if I make this curve, I am still highlighting, but I want to remove this because this is not my actually object of interest. Okay, so what I do, now I try to make this type of curve, and you see that only this is highlighted. Now you will question that why this, why not here, why not here, right? So again, this is hit and try method. There's no, I cannot say to you that this is the method that you can try. Okay, so in image processing, most of the methods are hit and try method. There's no, I cannot say to you that. So yes,
We can use this for example to move
to remove something, to highlight something else. Okay, let's say in medical image, also we can highlight some parts and remove the other parts. Okay, so we call this a gray level slicing because we slice them in some part, we slice them. Okay, or also the intensity level slicing. Again, this is like simple example. I want to keep the intensity 50 to 150, is set to like the highlighted. The others, I just make it the 0. Okay, so I think it's a simple example. Why I'm giving you the micro example just to make sure that how it will be applied. Okay, in your mind. This is again another very good example. Let's say this is the image. I applied this method. Okay, with the higher intensity values, I make it darker, and the other one I make it 0. So if you see, this is actual image because there is some person as well. You see this shade of that. So I removed that one and only highlighted the inside arteries maybe. Okay, and then this image is even clearer than this one. What I did, I just make this portion only down. So now this is like different task. Maybe try some method, see what is the effect, and then try to do something else. Okay, again, real time example. You see this image, you cannot see anything here, right? So what I'm doing is I will try to make this. You see, if I make this brighter, what will happen? You will lose this information. If I make it darker, you will already you don't have something, and you even make it darker, right? So I have to compromise. It's a very good example, right? So what I have to do is I take the higher intensity as is. Inside, I make it a bit higher, and you can see the things start to appear.
just find where exactly.
Yeah, you can do different adaptive methods if you want to, but normally it's a hit and try. Okay, let's say if you have a MATLAB program. So I have these two from A to B. Let's say I define these values, so you can start changing and start seeing where the so it's like a sliding window. You can slide it single, then it can be okay. So this again is the piecewise method. Clipping, again, clipping is what make 0 to A equal to 0 and B to L equal to some higher value. Inside is just a linear curve, and you can see that this increases even the contrast more. Okay, this is like a contrast enhancement, right? Okay, somehow related to that, but with some specific.
Here what it says that the intensity from 0 to level A, I don't know what the number is, for example, keep it as this, don't do anything.
Level 0, make it dark.
Yes. And B to L make it high. Okay, and this again the contrast enhancement, and you can see that this and then because it increases the contrast, this method is actually a special case of contrast enhancement. Okay, so why it's called clipping, because these values are 0. Okay, so you can see.
200 is 0.
Yes, it's above 200 is the maximum.
It's like removing some of the values from the values of the
Not values.
remove, I think.
Not removing, you can say, but again, the thing is making some the darker more darker, but there it was like more darker, but here the darker ones I am just making the absolute black, and the lighter ones make it lighter. Okay, the brightest one. Okay, so I think this is again simple example. Now, okay, so what are the advantages and disadvantages of these methods? Disadvantage, yes, disadvantage is quite simple. Just have a curve, this and that, put the value. No much calculation. So that the advantage is the easy, but disadvantage more input is involved, right? But there are other advantages and disadvantages, like less processing is required because you don't need to store anything. Okay, so yeah, so again, it's a limited scope, oversimplified. We can have artifacts if you don't make it proper thresholding or something. If you have a noise in the image, if you not handle that, suboptimal in some of the complex problems. Again, for complex problems, this is very simple approach will not work. And but again, we have the advantage. We have a wide range of applications. Less memory, speed is more because you just have pixel by pixel. Simplicity, parallelism or parallel processing, because you don't need to go by pixel all. You can take all the pixel and do the operation, right? So it's like a parallel processing. So these are all the advantages. So now, because I think the biggest disadvantage is this one, as you mentioned. Okay, user input is required. So solution is okay. Now, what is the histogram? I will stop it here. This is the topic of next class. But just to make you think about it, we talk about the probability, right? So let's try to use the probability in the processing. Okay, how? What is, by the way, just what is histogram?
So that's the implementation of the values of it. Like, let's say the CDF.
CDF or PDF?
CDF.
PDF. Yes.
Yes.
Okay. So we talk about the probability, right? Each pixel has some probability. What is that? The number of times it's repeating divided by the total number of pixels in that image, right? So number of times ZK is repeating in the image divided by the total number, right? This is the probability. So if I plot this together with, okay, so what are the pixel values? Let's say for 3 bits, what will be the level? 0 to 7, right? So if I just plot from 0, 1, 2, 3, and 7, this is pixel, okay, ZK, and then plot the probability of each pixel. Okay, this will be just a number, right? So what is this? Is P of that K. This is just histogram, nothing else. This okay. And if I add all these, will get me equal to 1. And if I start to add all, like for example, this is 0.1, it cannot be greater than 1, right? This is 0.2, let's say 0.3, 0.5. So what is, if I want to do the CDF, it will be addition of this. So it will be like 1, then 3, okay, and then yeah, 0.8 and like this, and it should go to 1. Okay, but PDF normally we will not really use, just PDF will be okay. Okay, so if I have an image, you see this, and what did you notice? This image has histogram of this image has histogram of this. Which image is better? Other one. What about the histogram here and there? Exactly. So if I make the histogram of image uniformly distributed, I can change the image to more good image, not brighter or darker. Okay, previously you were trying to have bright or dark, but histogram visualization is a very good approach that will make the darker lighter or lighter darker. Okay, just like there is no much user input here.